Hello everyone, welcome back to the channel. So today we are going to talk about deployments. Suppose it's 2 a.m. and your application is running perfectly fine in Kubernetes. Suddenly a pod crashes and your website goes down. Customers can't access it. The orders stop coming in. The revenue is lost. And now here's the question. Will Kubernetes do it automatically, will fix the problem automatically? And the answer lies in one of the most powerful Kubernetes object, which is deployment. By the end of this video, we'll understand how Kubernetes can automatically heal the application without any human intervention. Now, what is a problem? Problem with standalone pods. In the last video, we learned about pods. Pods are where our application runs. So we'll create a simple pod, everything works, users are happy, life's good, but then pod crashes. Nothing, the application is down. Users start seeing error. And Kubernetes does not automatically bring it back. That's why running standalone pods in production is a very bad idea. Now, what is deployment? To solve this problem, Kubernetes introduced deployments. Think of deployment as a manager for your pods, and its job is to create pods, monitor pods, replace failed pods, scale pods, perform updates, and even roll back changes if something goes wrong. So, in production environment, almost every application runs with deployments. So, the deployment architecture is likewise the deployment replica sets and then pods. This is one of the most important interview questions as well. So many people answer like deployments directly manage pods, but that's not true. The actual workflow is that deployment first creates a replica set and then the replica set will create the pods. So remember this deployment will does not directly manage the pods, but it is replica set is a component which is responsible for maintaining the desired number of pods. Now in the real world analogy, let's understand with simple example. So imagine a restaurant. The owner is deployment, the restaurant manager is replica set, and the worker are the pods. Creating deployment is surprisingly very simple. The most important field here is replicas. Notice we have a replica set to 3. This means Kubernetes will always keep 3 pods running, not 2, not 4, exactly 3. The desired state becomes Kubernetes mission. What exactly happens internally? When we apply this deployment, Kubernetes creates a deployment object. Then it creates a replica set. Then replica set creates the pods. And final result looks like this. Deployment, replica set, 3 healthy pods. And Kubernetes continuously watches them. Self-healing feature. Now the pod crashes, replica set detects it, new pod is created. Now this is the magic. Suppose pod number 2 crashes, normally your application would be in trouble, but Kubernetes notices it immediately, replica set sees what I should do with 3 pods. Now I have only 2, and within seconds a brand new pod is created. No human intervention, no late night emergency. This feature is called as self-healing. And it's one of the most biggest reasons company love Kubernetes. We'll understand scaling deployments. What if your application suddenly becomes popular? Maybe a marketing company goes campaign goes viral, traffic doubles. Instead of manually creating pods, you simply tell you Kubernetes I want 5 replicas, and Kubernetes will automatically launch additional pods. These pods become 5. So from 3 it goes to 5, 5 becomes 10. This is the foundation of Kubernetes scalability. We'll understand rolling updates. Now imagine if an application is running a version 1 and there is some updates due to which you have to deploy a version number 2. Now in traditional environment, this often causes a downtime. Users see few errors, application becomes unavailable for some time, but deployments solve this problem. Kubernetes update pods one at a time. While some pods run on version 1, others start running on version 2. Users continue using the application without any interruption, and this process is called as a rolling update. We'll see few important commands. kubectl get deployments, kubectl describe deployments. So kubectl get deployments is where we can actually view the deployments that are happening. Describe deployment will give us to inspect the details, and kubectl rollout status will help us to monitor the updates, and kubectl roller undo to roll back if an update fails. So generally, if the application is down, we can use this kubectl rollout. So these commands are used almost in daily in real-time productions. So we'll go ahead with a few interview questions to test your knowledge. Question 1: what is deployment? Who manages the pods directly? Deployment or replica set? What feature automatically recreates failed pods? What is rolling update? You can answer these questions confidently. You are already ahead of many Kubernetes beginners. Let's recap. Pods run application, deployments manage pods. Replica sets ensure the correct number of pods are running. And deployments provide self-healing, scaling, rolling updates, rollbacks. This is why almost every production Kubernetes application uses deployments. In the next episode, we'll dive a little deeper into replica sets, uncover the hidden component that actually keeps the pods alive. If you're enjoying the Kubernetes Zero to Hero series, hit subscribe, turn on the notifications so that you don't miss the next lesson, and tell me in the comments what's most impressive to you, self-healing or rolling updates. Thank you.